Hey, welcome. So today, we're going to tackle a topic that, let's be honest, can look pretty intimidating, multiplying radicals. But we're going to break it all down into a few simple, powerful steps. And by the end of this, you'll be handling these problems like a pro. Okay, let's get into it.
All right, just look at this thing. Seriously, how would you even start? It's like a complete jumble of numbers, variables, and those little square root signs all over the place. But I promise you, this is not nearly as scary as it looks. In just a few minutes, we're going to come right back to this exact problem, and you will know precisely what to do. So, where do you even begin with something like that? Well, it all starts with just one, foundational rule. If you can master this one thing, you've basically mastered the core idea of multiplying any two radicals together. And this is it. The product rule for radicals. Sounds super technical, right? But the idea is actually really simple. Just think of those radical signs, the square root symbols, as little houses. As long as the type of house is the same, like a square root house and another square root house, you can multiply the numbers living inside them and then put the result back into one single house. And this right here is the absolute key to that rule, the non-negotiable part. On the left, with the green check mark, you see two square root houses. Their indexes are the same, so you can go ahead and combine what's inside. But look at the right. You've got a square root and a cube root. The houses are different types, so you just can't multiply what's inside. The houses have to match. Simple as that. Okay, so what does this look like in practice with numbers out front? It's this super simple mantra. Outside times outside, inside times inside. That's it. For this example, you multiply the numbers on the outside, the 5 and the 4, and you get 20. Then you multiply the numbers on the inside, the 2 and the 3, and you get 6. Slap it all together, 20 times the square root of 6, and you're done. Okay, awesome. So we know how to multiply. But that's only half the battle. Getting an answer is one thing, but getting the simplest possible answer, that's the real goal. This is where the magic happens. This quote really nails what we're trying to do. Our mission, really, is to peek inside that radical, the radicand, and see if there are any perfect squares hiding in there that we can pull out. It's kind of like digging through a messy drawer for a pair of socks. Once you find a matching pair, you can pull it out and set it aside, right? Same idea here. And these numbers right here, these are the ones you want to be on the lookout for. Seriously, think of these as your cheat sheet, your best friends when you're simplifying. Getting familiar with perfect squares like 4, 9, 16, 25, and so on will make your life so much easier. All right, let's put this to the test with the square root of 48. Now, your first thought might be, hey, 4 goes into 48 and 4 is a perfect square. And you'd be right. But here's a pro tip. To save yourself some steps, you always want to find the biggest perfect square that goes into it. In this case, that's 16. So we rewrite 48 as 16 times 3. We split them up into their own little houses, and because the square root of 16 is a perfect 4, it gets to break out. The 3 stays behind, and there's our final answer, 4 root 3. Okay, you've made it this far. We have our 2 key skills down. We know how to multiply, and we know how to simplify. Now, it's time to put them together into one powerful process. And honestly, it really just boils down to this 2-step recipe. Step 1, you multiply. Use the product rule just like we did. Step 2, you simplify. Take the results and clean it up by pulling out any perfect squares. Multiply, then simplify. That's the rhythm. Okay, let's see this 2-step process in the wild. We've got the square root of 12 times the square root of 6. Step 1, multiply the insides. Boom. 12 times 6 gives us 72. Step 2, simplify that square root of 72. We hunt for the biggest perfect square that goes into 72, and that's 36. So we rewrite it as 36 times 2. The square root of 36 is just 6, so it pops out front, leaving the 2 inside. Final answer, 6 root 2. Awesome. We're getting the hang of this. But what happens when we start throwing variables, letters, into the mix? Don't panic. The exact same rules we've just learned, they still apply. There's nothing new to memorize here, I promise.
So when you've got exponents inside a square root, there's this amazing little shortcut. All you have to do is divide the exponent by the index. For a square root, the index is always 2, right? So you're basically asking, how many pairs can I pull out? For x to the 5th, you just ask, how many times does 2 go into 5? Well, it goes in twice with a remainder of 1. That means 2 pairs of x's get to come out, that's our x squared, and that one lonely x that was left over, it stays inside the radical.
Okay, let's see a full example with everything in it. First, we multiply the insides. 2x times 8x is 16x squared. Now we simplify. What's the square root of 16? It's 4. What's the square root of x squared? It's x. Both of them are perfect squares, so they break out completely, leaving us with a nice, clean 4x. See? Same process. All right, we have built this up piece by piece. We've got a solid foundation. Now, we are ready. It is time to go back and face that monster problem from the very beginning. And to do that, we just need one last tool from our algebra toolbox.
And that tool is FOIL. You've probably seen this before. It's just an acronym, a little memory trick, that gives us a roadmap to make sure we multiply every single piece. F is for first terms, O is for the two outer terms, I is for the two inner terms, and L is for the two last terms. It just keeps us organized. Okay, deep breath. Let's go back to our original problem and break it down with FOIL, one step at a time. First, F for first terms. That's 5 root 2x times negative 4 root 2x. Outside times outside, 5 times negative 4 is negative 20. Inside times inside, root 2x times root 2x is just 2x. So we've got negative 20 times 2x, which simplifies to negative 40x. One down. Next, O for the outer terms. That's 5 root 2x times root 5x. Okay, outside numbers. 5 times 1 is just 5. Inside, 2x times 5x is 10x squared. Now can we simplify that? You bet. That x squared comes out as an x, leaving us with 5x times the square root of 10. 2 down. Now for I, the inner terms. That's root 5 times negative 4 root 2x. This one's a bit easier. It just becomes negative 4 times the square root of 10x. Nothing to simplify there. And finally, L for the last terms. Root 5 times root 5x. That gives us the square root of 25x. And we know the square root of 25 is 5, so that pops out, giving us 5 root x. Phew, we did it.
So after all that multiplying and simplifying, these are the 4 pieces we're left with. The last thing we do is check, can we combine any of these? Are there any like terms with the exact same radical part? And if you look closely, nope, none of them match. So this right here is our final answer. It looked impossible at the start, but we just broke it down step by logical step. And just like that, you've seen the entire process. From the one basic rule all the way up to tackling these complex binomials. You've totally got this. But it does raise a pretty interesting question, doesn't it? You know how to multiply them, but what on earth do you do when you need to divide by a radical? We'll get into that next time.